Hello friends, today we will learn how to fabricate the offset transition. As you can see in the 3D drawing, this is our offset transition. You can see both the center lines are not matching with each other from the top and the bottom. If you draw the center lines, these are offset. In our previous video, we have fabricated a segment for the normal transition piece. It was not the offset. Here I have some figures, the die, the height, and the rectangular, the bottom rectangular. Now I will draw. This is my top radius, and now the rectangular piece. For example, I set this at here. If I check from the center point, this is 25 millimeter offset from the top line, and from the other side is equal. You can see this is my diameter. From this side is 150, from the other side is 200 millimeter. And now I will draw the side view of my transition. As I mentioned, the height is 100 millimeter. This is my 100 millimeter, and from the top the diameter is also 100. Now I will put the symbol of diameter, and from the bottom is 200. These are all dimension from the top. You can see. Now I will divide the circle into 16 equal division. And I will match. I will put some line from each corner. These should be 4 equal division. It means at each 90 angle you need some points. For example, I put this in the center of the circle. Look here, the bottom and the top. I have some points for division. This is too necessary. If the division is not like this, then you cannot fabricate the correct transition piece. This is too necessary. I divide into 16. You can divide into 24, 20, something like this, but it should be divided by 4 equally. Now all the lines are here, and I will remove these unnecessary lines. And now I can mark them. You can mark them either clockwise or anti-clockwise, it's up to you. This is not necessary, but you need to remember where are you going, and we will see in our next tables that where we are going to the clockwise or anti-clockwise. So edit them all. Now you can edit and edit. This is number 13, number 14, 15, and the last one is 16. Now I will make a table from these dimensions. For number 1 I have the dimension of 103.8. For number 2 is 83.6. As you can see, further and further. (103.08) for number 2. I will make this table. It will help me for further calculation. Now remove all the dimensions because we need new dimension for other points. But you can see this number 5 is touching with both the corners, this line and this line. Now I came from clockwise, then number 5 I will add this number 5 2 times because it's touching with both corners. Same like this. The same practice we will repeat here for all the lines. And we will complete our table. Note them all. For this number 9 both are equal, that's why I will mention only one time. You can mention this number 9 2 times, it's up to you. If you see this number 10 and number 8, these are equal. Number 11 and number 7, these are equal. You can see from both sides the dimensions are equal. Because the center is offset from one side. complete the table. This number 13 is also, it have two dimension, because this number 13 is touching with both the corner, same like number 5. So I will mention 13 two times because we have two dimension in number 13. So this number 1 is also touching with both corner. So either you can mention one time or two time, it's also up to you. This is my table. Table number 1 is completed. Now if you remember, we need the arc length of one segment. I will cut it from here and check what is the arc length. It's 19.63. This is the gap between each segment. I will add this in this table. And delete the unnecessary dimension. Now this is my 100 millimeter height. I will draw a line of 100 millimeter and the other horizontal line. This is not necessary how long it should be. Now at number 1 I will draw a radius from this corner to the horizontal line, and where it's touching I will draw a line. This is my number 1. If you remember, in our previous video we did the same practice. This is my number 1. Number 2 is 83.6. Now this is number 2. Number 2. I will change the color because I need now the table number 2. This is table number 1. All the dimension from the plan view we have put in table number 2 or number 1, and in number 2 from table number 1 we will get the dimension for table number 2, same like this, 143.62 for number 1. Now remove all these dimensions in table number 2 because we need the dimension made for table number 2, but we can calculate from the top view. Now this is blank, and number 2, what is number 2? 130.34. And now number 3, 65.47. okay, match the line to the top. It was too close, that's why I put this up. Now this is number 3. Now you can see this number 2 and number 16 are the same dimension. They have the same dimension, 15 and 3, 4 and 14, 5 and 13. So you can copy these dimensions for the other side. Same, this 2 is similar with the 16 and 3 is similar with 15. That's why don't waste the time, just mark up there. This 2 and 16 are same, 3 and 15 are same. And now number 4, what is number 4? 54.12. okay, draw a radius. And now this one is number 4, and complete your table. 113 point, here add it, seven one. This number 4 is also matching with number 14. Both are same dimension, both have same dimensions. So 4 and 14 are same. Now we have 2, 5, 5. This is my first 5. I'm coming from the clockwise, so this number 5, this is the first one, 114.56. Same like this. I'm going the clockwise. The second number 5 is 134.63. Draw a radius and match this line. This is the second number 5. I draw a radius from the corner. is touching here, and I will mention this number 5 in my table. Now look, this 5, 5 and 13, 13 are similar. Draw a radius for number 6, 118.75 from the corner. Now draw a line from the top to this point. This is my number 6. Now as you can see, this 6 and 12 have the same dimension. 7 and 11 have the same dimension. 8 and 10 have the same dimension. So I can copy these dimensions for the other side, or you can calculate one by one. Be careful while you are copying a dimension for the other side. This number 9 is also touching with two corner. As I mentioned one time in my table number 1, and I told you it's up to you. You can mention 2 times, like we have mentioned 2 times the number 5 and number 13. You can also mention this number 9 for 2 times, but if the dimension are same, then no need to mention 2 times. Just need to remember Mistakenly I have copied the wrong dimension here, but you can copy the right one, the second number 5, 164, 167.21. This is my table number 2. Now I have complete table to fabricate the segment. Now you can see 150, 150, 200 and 200. This is my rectangular. You can start from number 1, but for me it's too easy to start from number 9. You need to just remember from where you have started and all the dimension, either the clockwise or anti-clockwise. You just follow the direction. Now if I start from number 9 and the bottom line is 200 millimeter, and this is my bottom line 200 millimeter, and I have number 9. Draw a radius from both sides, and the tangent point, they're matching, touching with each other. I will draw a line from both the edges, from both ends. Now what is the gap? 19.63. If you remember the previous video, we explained well. Now number 8, this is my right side, number 8. I will draw a radius 150.83, and look where both lines are touching with each other. Remove these circles and draw a line to the corner. Now I will draw number 7, 149 point something, 149 point. The same 19.63, and this one is my number 8, number 7, number 6 and 5. This is my right hand. The points are going like this. Now number 6, we have 155.25. I will draw a radius, and where they are touching, I will draw the lines. Look, all the dimension, all the segments are equal, 19.63. This is number 6, and now number 5. From here we need to focus a little bit, because this corner is completed. We have 5 dimensions. Now these are completed. I will go to the next dimension. This 150 millimeter side. So I will draw a radius of 150 from here, and from the top. In table number 2, what is my number 5, 114.56. I will draw a radius from the top, 114.56, and now draw lines from here to the corner, and same 19.63. Just draw the lines. Now is number 4, and number 4 is touching here. Now draw a radius for number 3, 119.53. This is my number 2. And the last one is number 1, 143.62. Now it's done. This 200 horizontal and the other side is 150. Now if I draw at my right side again, now it's done for 200 millimeter, this straight length. So I will draw a radius of 200 millimeter from here. And for number 1, the other side is also number 1, both are same. So I will draw a radius from number 1 to the corner and match with each other like this. Now I can mirror all these dimensions to the other side, because the other side is also they have the same dimension. Added all these numbers, because now this is the other side when I came from the clockwise. 1 2 3 4 5 6 7 8. This is number 15, this is number 16, and this one, when I will fold I will bend this sheet, this number 1 will match with number 1. Now this is my final segment, and this is 100 millimeter, and this 100, when they will match with each other, it will become 200 millimeter. So this is my final segment drawings. You can mention the dimensions for the fabricator for fabrication purpose. Thank you for watching the video.